So a little bit about myself. In my previous job, I used to work for Walmart. A lot of you know Walmart is one of the largest companies in the world. It has a tremendous amount of data. And as a technology person, one of the biggest pain points that we faced was trying to find out about what data we'll be working with. Like who owns the data, where is it coming from, where is it going, contacting the owners. It was a really big pain. It almost took us a month to just get started, even after we could figure out what data we need to use. All right, with a brief introduction on how I got into metadata management, let me start off. We were able to divide the problem statement into three parts. A data dictionary. What data do we have? A data lineage. Where is the data coming from? Where is it going? What are the upstream and downstream dependencies? What are the transformations happening? And finally, the biggest question, like data ownership. Who owns that data? In this presentation, I'll be mainly focusing on data lineage and data ownership. Okay. So why did we choose Neo4j in the first place? There are plenty of other databases out there. Most importantly, it's a graph database. And why a graph database? It's super easy to solve for lineage problems using a graph database. And it has a free community edition, which is amazing if you ask me. And it has SDKs available for the most popular programming languages. We are using .NET, by the way, in case you guys are wondering. And we had another criteria that it should also be used as a vector store. I won't talk too much about that, but it fit in nicely with what criteria we had. Okay. Now, initially, we didn't want to make our own view. We wanted to go with the default Bloom browser view. And we're like, hey, this should be more than enough for all our analysis and metadata management, right? No, we had some pain points. In order to get this view, we needed to know the cipher syntax. And the more the complicated the graph, the more it was harder to navigate here. And also we had to answer questions like, hey, when was this graph node last updated? When was the graph almost last updated? Who updated it? All the interesting things about data. So we built our own. Now here's the high-level view of what we did and high-level view of our solution. So first thing we figured out was we had to clean up the data and we had to organize our data in a consistent manner. So we had to put it in a structured format. The other thing is we had to build our own visualization dashboard, which I'll show you in a minute, to visualize the data and its relationships. And it also has a small module to manage the metadata, where you can add or update the ownership info of individual nodes and relationships and stuff. Okay. Now let's go to the thing that you guys are waiting for. When we started building out our visualization dashboards, we could break out our data visualization into two categories. The first category was data lineage. So what's this data lineage about? So let's say there's a person, like the lineage of the person. First question about the person is like, what's the lineage of the person? What's his parent? Who's his grandparent? Who's his great grandparent, etc. And next, who are the descendants of the person? Like, what's the person's child's name? Who's his grandchild? Who's his great grandchild? This is the kind of questions that you can answer in data lineage. Who are the descendants and who are the precedents? I hope data lineage, the concept, you guys got it. Next, we had to implement a specialized type of data lineage, which is a kind of hierarchical visualization. Like this was more real world hierarchical visualization. For example, one real world example I want to show on my screen is, let's say there's a bank at the top, and a bank has four departments. Let's say the four departments are investment, retail, treasury, and custody. And let's say each department of the bank has multiple services and multiple databases. And let's say every database has like hundreds of tables, and every table has tens of or even 100 columns. That's another kind of visualization we want to show. Now, enough with the boring PowerPoint presentation. Let me show you how we achieve this. Just give me a minute. Let me share my this one. All right. This is from where we get our visualization from. And if you see all these are all fancy names for our saved Cypher queries. So let me click on this high level demo one, and let's see what kind of, oh, nice. This is the kind of graph that we came up. Now, like I explained about the four departments of a bank: treasury, retail banking, custody, and wealth management. Now I want to know what's inside treasury. Let me go to the next level. I want to check what's inside treasury. Now, I see something called user reports here, which is a part of treasury. I want to see what's inside this user reports. User reports consist of like this crazy kind of, it consists of some trade extract.xml, mark to market report, and data extract. Now, I want to find out the lineage for the mark to market report. Where is it coming from? Right now, you can see only one precedent, which is data extract.exe. Let me try and find the lineage of this. And let me give you a more better view of the lineage. Voila. And if you see, there's a mark to market report which reads from data extract, and this gets its data from these tables, and these tables gets its data from somewhere else, and this gets its data from somewhere else. So this is what I meant by lineage and hierarchy. And we can also display this lineage and hierarchy in a different format too, if we really want to. So we have multiple formats, multiple kinds of lineages, and all the good stuff. Now, how did we achieve this? This is what I want to show you next. So let me stop sharing my screen, and let me go back to the slides. And so I want to show you how we organize the data. So in a graph database, how is the data stored? So data is stored as entities and relationships. Thinking of entity as a different word of for nodes. So entity one is related to entity two. And so let me first talk about entities. So what's this entity? An entity can be anything: a cat, a dog, a person, a system, a script, anything. And entity generally has multiple attributes. One example entity I've shown here is person, and it has multiple attributes. So identifier, name, description. Now, one difference between how we implemented this and raw Neo4j is Neo4j is optionally type safe. That means, hey, an identifier can be anything. It can be a string, an integer, anything. But we are very strict about type safety because we have faced so many issues when we don't follow type safety. So using our tool, we set identifier as an integer. You cannot add a string to it or do anything else. So that's what we meant by type safety. Now, what are relationships? A relationship is, let's say there's two entities, persons, and Peter is a friend of Paul. Okay. Now in Neo4j, you can say Peter is installed in Paul. It doesn't prevent you from doing it. But we found out that we have more problems in doing in not having type safety. So we created type safe relationships. So using our tool, we restrict like uh, you have to say like Peter is like two persons can be okay, should have the relationship is a friend of. It cannot have the relationship is installed. So otherwise it will throw an error. Now let's go back to the demo and let me show you how we implemented this. So previously I was showing you a graph about a bank, and let's show you. And by the way, all this, whatever you're seeing on the screen is all powered by Neo4j. So just in case I showed you a tabular data in a tabular format, please don't be under the impression that, hey, you know what, this guy is showing some mock data, everything is live. This is from Neo4j, from the free edition, community edition. So if you see here, there's a node name called bank. It has a property name, and it has a data type string, and it has a system ID, sys ID, and it has a data type integer. And we support, these are the kind of types that we support, a Boolean and enum. We even support enums, by the way, integer, float, string, local date time. Now, how do we generate these graphs? Let's see how we generate these graphs. So I go to bank. Again, these are all powered from this. It's getting all this data from Neo4j. So I just select some stuff and I say, hey, I want to create a graph and let's see what happens. Boom, a graph is created. And like I showed you before, I can go to the next level. I can view the lineage and all that good kind of stuff. All right, let me go back. There's one more aspect remaining. So let me go back and share my, this one, window and PowerPoint slideshow, and boom. There's one thing remaining, which is manage data. So we also built in an entity management system. We can assign an owner to an entity. Again, assigning means just add a relationship. View all the entities provided by a user. So let me go back to the demo and let me show you how we did it. So let's go in. So I can ask it questions like view details, and I can find out who the owner of this market report is. I can add an owner. I can delete an owner, all that good sort of stuff. Okay, let me go back. I believe we have very less time, so feel free to answer all the questions here. And let me also share where, in case I won't be able to answer all the questions here in time before the session ends, feel free to contact me for more details at pavan.kumara@speda.in or connect with me on LinkedIn. I will be very happy to answer all your questions. Uh, it, uh, so please start entering your questions, and there are other people. No questions. Okay.